So my name is Zhumakhan Amirzhan, and it's again Mr. Vadim Tsurikov with us. Today we are having the brief explanation of our theme. So the presentation name is Simple Ecological Engineering Robotics. And so before we start, I would like to introduce a bit about ourselves. And so here's again Mr. Vadim Tsurikov that have worked with BMW in Germany for the last 2 years. And so he's a founder of KazSpace. And again, with Mr. Vadim Tsurikov, we actually had a 10 tree planting campaigns around all of Kazakhstan and planning to do it all around the globe. And so if we'll go to tell about myself, I'm a winner of National Science on Stage Europe 2024 contest that is held among the teachers, among the projects of teachers. And so today we're going to speak about this a little bit too. So if we'll speak about what do we want at this particular moment with this presentation, we'd like to stop on goals and objectives first. So first of all, as we all know, there are some sustainable development goals that are now somehow trying to be integrated in our life. And so I would like to point that our project is mostly focusing on the fourth, the quality education, 13, climate action, and at the 15th sustainable development goal. And so to start with our topic, I would like to introduce you some of the schemes. Nobody actually likes them, but I think that we should start to move from them. And I'll actually explain you why it's not as complicated as may seem. So here we have a science and many STEM connected spheres. And so basically, what we were trying to do is to develop our own new view on this kind of things. And so science starts with biology, chemistry, physics, and many other things, but eventually it all goes to robotics and automation. So how it all began? Actually began. KazSpace Academy was never ever thought to become the way it did. And the same I can say about the learning programs that we developed through the time. But if we'll move to the initial idea, it was never expected to become something global, but actually what it was pointing at as it's first of all that where we're trying to make our future a bit more predictable. And how to make our future predictable is to teach children something that you think is how to say it, that you think is really matter this world. And so we were actually starting with informatics and eventually going to plants. That's how we've connected the informatics with plants and created some kind of robotics that is connecting ecology, engineering, and other stuff. So let's start with the simple timeline. So it started with simple idea that informatics itself is boring. I mean, those of you who ever tried to become a coder or programmer from scratch and if you'll actually sit and do only programming without creating any kind of objectives that are involving you, you're not going to last long. So first of all, we started with integrating plants to our learning strategy. So first of all, one of children decided to help us with developing our education system. And so he brought the plants that we've actually planted next time. And then eventually 1 month later, the salads were ready to eat. And so as you might predict, we weighed them and they were damn so 3 months later, we've created an artificial lighting that gave us an opportunity to clone the trees, to clone many other plants that were then involved in the teaching process. And so 4 months later, we created a green box that is actually like kind of greenhouse, but in miniature. And so going one thing at a time, by going step by step, we've created a thing that actually brought us to the point when children became a little harvesters, a little engineers, and a literal kind of engineers of the new time, because we were never thinking that children are able to do some things, to do these things. And eventually, I think they were adapting themselves before they ever done. And so here are many other concepts. We were developing concepts of new cities and many other stuff, but it was fun. It was fun. And 2 years later from the starting, we've actually started to create our own art of growing trees. We've started to make interesting forms and many other things. And so also tree distribution campaign started approximately this time. And so as we've moved forward, we understood that actually there's nothing that much complicated. But what we have to do is actually to create kind of program that can help us to get theory with practice. And that's what we've done there. So introduction to 3D modeling and engineering and robotics actually started 2 years later. So here you can see many pictures of our children that were developing some kind of interesting ideas. We were not always ecologically we were not we were ecologically well. Ecological objectives were sometimes children get bored, and so we've tried to change some points and actually give them some fun. We've tried to create space stations on Mars. We've tried to create planes that were actually flying by radio control and all that stuff, integrating robotics to the science. And so 3D modeling was one of the points that we used to actually to engage some of our new students. And so moving forward, we were little engineers. We were trying to make houses, again, some space stations, some robotics hand that are actually doing. I mean, if you've ever heard of Curiosity or many other space strategies that countries use, you'd be fascinated with how these ideas can actually inspire children to do something like that. And so moving forward, we were trying to create a program that is, we're not only trying, but we've actually created eventually. So programming and much more. So we've included many platforms that were Tinkercad, that is the code, the blocks of code that are actually easier for children to understand. We've integrated an Arduino that is a small computer, in fact, and you'd be surprised what first or second graders can do with Arduino and a teacher that is actually interested in teaching it. And so moving forward, we've actually started with Wi-Fi, with many other technologies. And so bringing them up together gave us the result that we've got in the end. So moving step by step, making our world, making our children, making our society a bit better by involving ourselves and by involving children at the world of technologies and science from the young age as a way to contribute to the future. I think it is a key. It is a key that we found. And so 6 years to our time, we've actually tried so many things that are hard to imagine. Here you can see a little timeline maybe that's gonna fascinate you. Here is the stages of growing up these plants. And so I'm not sure how they are called on English, but those flowers, I think you know them. And we started step by step by eventually growing them up. And so isn't it the best the best showcase of how diligence and hard work of both children and teacher can bring result to the real world. So to conclude with, our world is facing challenges all the times. And so it may seem that our world is complicated now, is getting complicated in the future, but in fact, we've always had some problems. But problems are to be solved, and new challenges of our times may include AI, may include many other stuff, but actually, it's the mindset that is actually going to move us forward. And it's a mindset that we can actually teach our children to do. So there is nothing impossible. There is theory and there is a practice. They should go together. So there are many other stuff that we're trying to make. And as a final result of all our studies, of all our working experience, uh, we've started developing our own teaching construction. I mean, the kind of toy that is actually going to teach our children to think out of box, to create their own smart city, many other smart decisions, IoT decisions, and so on. To actually connect them out, connect them by themselves, to program them, and to understand how world around us is working. So we started with simple informatics. We've started with simple coding that is never interesting by itself, and eventually moved forward to the things that can actually fascinate ourselves. And so here is the best. I mean, that's a good example of our project. And so currently we're still working on it. But we've got some interests of many other teaching centers. And so moving forward, I would like to conclude that there is only bright future ahead. But the question is, how are we going to get to it? And so our answer to this question is we're planning to integrate STEM, to integrate ecology, and to integrate, first of all, critical thinking in the minds of our new generation. Thank you for your attention. I'm ready to get some questions if I'm allowed, though. And anyway, it was a pleasure presenting this to you.
Thank you so much for this very energetic presentation. And I'm sure there will be questions. So there is one. How can we effectively manage a demanding coursework schedule while ensuring we have sufficient time to engage in STEAM projects? What strategies or solutions do you recommend to strike a balance between coursework and project commitments?
Well, as far as I understood the question is how to actually manage theory with practice. And so simple as it is, simple as it may seem, that is actually kind of a hard thing to implement. And so here are some things that we've done by ourselves is that we're not trying to make a theory lesson and a practice lesson. We're trying to make a theory and then a brief practice, and then again a theory, and then again a brief practice. Sometimes we are giving our children throughout the lesson, we're giving our children some kind of challenge tasks that they're not able to complete with their knowledge. But what it actually moves them forward is that again, to make children interested in theory, you have to show them that they need it. And so how is that? How are you going to show them that you need some theory? First of all, you're going to give them the task that they're not able to solve. And so that's one of the ways that I can suggest. And the second way is just simply, again, by creating small sections of theory and practice. So how do we do it with robotics? For example, everyone knows light bulb that is actually lighting. And so we have to, so there is this, there is as a hard concept of alternating current that is moving in our buildings, in our cities, and all that stuff. But how do you actually teach a kid to this? We've created some stories. We've created stories of we've created a character that is helping children to understand the things. We've created a character that can actually connect children with the understanding of what programming is. And programming basically is just controlling the flow of electricity. And so how to explain it? We've explained that Ampere, as you know, Ampere, maybe it's a character that is actually using that is actually a small electricity king that is leading our electrons to the point. And so this Ampere is giving us some commands and programs. And so basically commands of that Ampere are programs. And so programs are programming. And that's a simple way to explain it. I mean, it's a hard thing to do. When you are a teacher, you always have to be sure that you're understanding everything fully. And if you understand everything fully, you're able to actually give a analogy to children that they can understand. I mean, intuitively. And that is how we've actually made our first and second graders to actually connect this kind of wires that some students cannot at universities. And so I think there is no any right answer to this question, but I'm just giving you my own view on it. And so it proved to be true for me. And so that's it. Maybe you got any questions that I can help you with too.
Thanks for your answer. There is there is a comment. Well done in motivating our future leaders. I'm excited seeing the children through the activities. Congratulations and well done. And there is a question. Excellent. I just want to know how long these courses were and what were the initial observations about the learning attitude of kids of such advanced concepts? How these were made easy for students? Sorry for long questions.
Oh, that word. I'm actually fine with that. When there are long questions, it means that we can conduct something on them. So first of all, how long these courses were? Well, it actually started pretty much 7 years ago. And since that time, we've tried many strategies, many learning courses. And what we've actually understood is that there is no anything like not from our world. There are things that you've got around yourself. You don't actually have to invent something from the beginning. You give people, you explain them the things that they already know, or at least they think they know. And then you start to see the progress in their lives, in their minds, because they're actually starting to understand something that may seem obvious quite deeper, and it brings them creativity, motivation, and other stuff. And so initial observations about the learning attitude of kids. First of all, if you start with theory, if you bring up this, I mean, I can show you maybe here. Yeah, got it. A bit rough, but here is an Arduino. Arduino is simply kind of microcomputer, but if you show this to children and say, today we're going to code this and make this, and you have to understand what programming processes are, they actually get bored. But if you say that, you know what's this? That's the brain of any robot. That's the brain of any device that you have. That's the brain of your phone. It's the brain of your computer. That's the brain of your car. That's the brain of everything that's around you. They get really fascinated with that. And so as you'll give them, sometimes the lesson is not about what you tell children to do. It's about what you ask children. And since you're asking them, they're always involved. And tasks should be involving them too. For example, my first task that I give to children is actually show me a device that has some programming in it. I mean, Let it be a washing machine. Let it be an iron. Let it be, I don't know, whatever, television, TV, whatever. So they're actually trying to show how it works, and it's actually interesting to see this. So that's one of the way how to make it easy for students. And I see a question from Irum Zahid. Sorry if I'm not pronouncing it right. So the links of our students, we actually have Instagram. I can leave it probably a chat as soon as I'll end my session. And yeah, that's basically it.
Okay, thanks. Yes, and there is a clarification about the previous question, the duration of each course for the children, apparently.
Excuse me, can you repeat?
Sure. There is this clarification to the previous question that you were answering about the duration of each course, I suppose, for the children. How long is each course?
How long is each course? Actually, we're breaking it to sections. It's approximately 3 months, and we're moving from section to section. We start with simple projects. As you can see here, we have a typical project of our student. I'm not with what is full with now, but it's actually quite an easy project. You have to create a little box with something inside of it, and they actually start pretty easily. First of all, they measure all that stuff. They measure. It can be whatever. You can use some tough paper, I don't know, and you actually create a small construction of this, a small box basically. And so you're buying some lights for this. You have some ventilation, and you have a small Arduino. So that's basically not more than I guess around $20 to $40. But it's not that much for a project that you can give for 4 to 5 children. And so they're extremely interested in that, because normally what we expect from teaching is you have to bring your notebook, you have to write everything down, you have to do that, you have to do this. But if you give them practice, if you give them simply work with your hands and with your head, with your brains, and ask me any questions if you have. I won't tell you anything. You have to figure it out yourselves. And when they ask questions, they're actually keeping that in mind, keeping answers in mind. But if you'd explain them in theory, they're probably like 90% of that theory is gonna evaporate from their brains as soon as they're going to leave class. So first of all, again, make it simple and yet make it interesting by involving children into that. So this project, from the beginning, from scratch, it takes approximately 3 months, maybe 2 months, with some smart children that are actually having some backgrounds working. But normally it's 3 months per every project. And so we're welcoming children to develop their own other projects. There are many other projects that you can see. And yeah, that's basically it. We're having our typical projects, but in case children are not interested in that, we're actually involving them in other projects that they can suggest us, or we can suggest them. That's it.
Thank you. Thanks. There is even a suggestion to interact or to collaborate with you in the comments.
No, it will be great.
So hopefully this session will be fruitful in terms of new collaborations and new amazing projects.
Sure, you can contact us. We'll leave our contacts.